Okay, I'm going to take the busted thermoelectric cooler. I'm putting it on the hot plate. Okay, so there we can see all the solder joints are melting. There's a little more mass in the back. I'm going to give that a couple moments here. Okay, let's see if it's ready yet. Not yet. Now there is a little bit of adhesive. It's a sealing that goes around the perimeter of the thermoelectric cooler. That may pose some technical difficulties. It may not. So I'm just going to use a screwdriver here to hold the bottom plate down while I try to loosen the top. Okay. So yeah, the sealing was sticking a little bit. And see that there, but okay. So what I'm going to do here is remove a few of these. Now there are little plates, if you can see that. It's probably a little piece of tin or something. I'm not really sure what the material is. Remember that the thermoelectric cooler works off the same principle, I believe, as a thermocouple, so we need dissimilar metals. And, hopefully you can see that. Maybe not. My hand's in the way. I can easily move the junctions around. So I think if we remove the perimeter sealant and allow this to heat probably approximately a minute, we might be able to reflow a thermoelectric cooler. So that's actually the purpose of testing this one here rather than what I would like to repair, is just to see the likelihood. Hopefully you can see that. It looks like my hand is in the way. Alright, now I'm just shaking some of these off because I have some plans for this particular ceramic substrate here because it has solder pads on it. That will be covered later. So what I'll do here is I'll just scrape these off because they're of no use to me at this particular point in time. I'll gather them up later. And while this heats again, but you can see this. Here's a busted piece of the ceramic substrate, and you can see I got fingerprints in it because I picked it up while the solder was still molten. This actually serves as an excellent prototyping platform, especially for high power applications, because we do have the ceramic substrate here. So it's a unique particular platform to have, especially if you would salvage it from a defunct thermoelectric cooler. Okay, I'm going to try to remove some more of these, hopefully without getting in the way of the camera. This is a very rigid platform too, by the way. Much more rigid than I had expected. So this is an excellent discovery. I'm kind of glad that I smashed this thermoelectric cooler just to see what was inside of it. I never paid much attention to them before. Given their price, it was just cheaper to replace them. But knowing that there's a substrate like this, it kind of changes the game a little bit. Okay. It does seem to be somewhat fragile when it's heated up to the temperature of which you can melt solder, evident by the fact that I just broke it. It also could have been micro cracks because I did hit this with a pair of pliers to smash it open. Particular substrate doesn't seem to be too bad here. Let's see if we can get a good view of this. You can see the excellent platform for prototyping surface mount. Okay, I'll clean the other one off here because I do intend to experiment with this now. I'm just watching the video here in the viewfinder, curious if I can see the solder melt. I haven't, I must have missed it or I couldn't have seen it. Yeah, I just didn't see it. Okay. If you could hear the radio station coming over my preamplifier, I apologize. That is not my particular radio station I would like to listen to. It just so happens that the radio station is strong enough to induce a signal in the preamplifier cable. And there, I broke that one. Okay, so they're somewhat delicate, I suppose, after you smash them, so do handle them with care. I would recommend that you clean your bench up and get a nice work area before doing so, although I don't seem to follow my own recommendations. Okay, so now I'm going to put the other thermoelectric cooler on and see if I can reflow it. Okay, here's the other thermoelectric cooler, which is open circuit. I'm just going to lay it on. Actually, I should probably... Yes, there's a sealant around the outside. I should show you that. It's probably some sort of room temperature vulcanizing substance. And then there's obviously remnants of the thermal grease. I'm going to remove the perimeter just so that the gravity has a better chance of reflowing this. I have some reservations that if I allow this perimeter on here while I attempt to reflow it, it's going to hold the top substrate and the reflowing is not going to be adequate or even successful. I'll be back in a minute. Okay, thought I would show this on video while I'm taking this apart. Underneath the excuse me, underneath the, I would guess you'd call this the hermetic sealant, is looks like a strip of tape, probably to protect the actual individual junctions, I assume. So that's something to watch out for whenever you're pulling these apart. Okay, I thought it might be interesting to actually get a reading. Let's see if I can find it here, of my voltmeter. There it is. Oh, we might not be able to see it. So I got -6 millivolts roughly while I reflow this. I'm just curious to see what happens here while it reflows. Okay, I'm going to place this on the heater there, and the voltage right now is 2 volts, and it looks like we have some solder melting. Just seen the wire move. We're at 2.3 volts. Okay. Now, I'm kind of curious here as to the best route to cool this. I suppose I will put the cooler on. I'm going to shut it off, and I'm going to put the original heatsink back on it in hopes that the pressure will be able to. Yes. Okay, now I'll allow that to cool, and then we will test the cooler, the thermoelectric cooler, after the hot plate cools down. Might be something worth thinking about. How can you get that off of there? Maybe put a tray or something underneath it so that you can move it and cool it more rapidly. This is going to take a while because of the mass of the hot plate, but we will be back. Okay, I'm pretty impatient here, so I wired this fan up here. Hopefully we can cool it down a little bit faster. And as soon as I get this cooled down, we will see what the results are. Here's another curiosity I wanted to check. I put my meter in current mode, so I got 378 milliamps. If I switch back to voltage, see I have 2.28 volts. So I'm thinking that I successfully repaired this thermoelectric cooler. I have a little bit under 1 watt output. So I'm going to hook an LED up now. Okay, I have a few LEDs here to choose from. I'm going to grab one of these high bright LEDs just because I think it'd be more interesting to see the light. And I will get it wired up and we'll see this. So it appears that the high brightness LED has a little bit higher forward voltage than what we're producing right now. I find that somewhat strange. 2.5 volts. I'm going to check another LED here. Okay, now we're back with a regular LED. This is driven at 2 volts. This is just demonstrating that the pelter junction does appear to be working. So it is certainly possible to reflow a thermoelectric cooler. It's interesting. Alright, once this cools down, we'll check it out. Well, the experiment proved unsuccessful. I thought I had my hot plate plugged into the variable transformer, but here it was plugged right into the wall. So I had the hot plate on, and I just shut the variable transformer off, thinking I shut the hot plate off, but I didn't. So when I came out here to grab the thermoelectric cooler, I just grabbed the wires, and it was still hot, and it moved the entire assembly, and all the little junctions came loose. So I didn't have any more power coming out of it either. So as far as I can tell, it was repaired until I bumped it. So I do believe it's possible to reflow a thermoelectric cooler. So now that all of the junctions have been misplaced inside, I'm going to remove the ceramic substrate and use it for a prototyping platform. So it's heating right now, and hopefully it's hot enough to be removed. Maybe not quite yet. Okay, hopefully you can see that. There's the thermoelectric cooler. And I will work on this 2 parts at a time. See if we can perhaps focus on this a little better. There we go. So it was half failure and the other half success, because I am very pleased that I discovered that I can find a ceramic substrate out of a junk part. And also each one of these little junctions here, the camera will focus here. It don't look like it. Maybe here we can look at it. Each one of these little junctions can be used as a thermocouple on a circuit board. So that's very good to know that, because these are not broke. Remember, I did not smash this particular junction. So what I'll do is carefully remove all these, as carefully as I can with the primitive tools I'm using here. And then I will collect them and carefully disassemble them, because these are in essence a surface mount thermocouple. The type I cannot tell you, but it's nonetheless interesting. And there is our rough surface mount prototyping platform on a ceramic substrate. Very interesting. Okay, now I can gather up my parts as soon as I find something to put them on. Okay, I have a piece of paper here. I'm going to put all my parts on. Okay, and there are our parts, which I will rework later. And now I will do the opposing side. So maybe we can get a little closer. Maybe observe the solder reflow. Maybe not. So here I will grab one of these. There we can just see it's just a little surface mount thermocouple. Strange noises outside. Okay. Okay, there's something strange going on outside. I need to go check that out. We'll part here, and then I'll pause this and continue.